Today we're going to divide polynomials, and to divide polynomials we're just going to do what's called a quotient rule, which simply means subtract exponents instead of adding them, like multiplication. So if I have 2, 8 over 2, 4, I'm going to subtract the exponents, so I'm going to get 2 to the 4th, which, because these are numbers, I can actually get my answer, which is 16. Now when we have variables, we're going to do the same thing, except that we won't be able to get an answer. So 13 minus 3 would be 10 to the x to the 10th power. Now remember, when there's no exponent, that's a 1, so 15 minus 1, this would be y to the 14th. So we continue with this. We also have certain special cases, and here's our first one, is when we have the 0 power, it equals 1. So no matter what the number or letter, this equals 1. So whatever the 0 is attached to, so this is also 1. But here's where it gets a little tricky. Look at how the 0 is attached to the 5, but not to this negative. So this is actually a -1, because 5 becomes 1, but the negative sign. Over here, on this problem, it's attached to the 0. Over here, the next problem is the 0 is attached to the x only, so it would be 10 times 1, so it's 10. Now, just like we had powers to a powers multiplication, we have the same thing in division. I'm going to distribute. This becomes x squared over 16, and there's my answer. Now when we have power to a power with the letters, we multiply them, so 2 times 3 is 6, but 5 to the 3rd power, which I believe is 125, is our answer for that. So if we continue on and look here, this would be 2 to the 5th power, which is 32, but 8, 3, and 5 will be 8 to the 15th, and that would be over b to the 20th. Dividing monomials is simply dividing the numbers, so -12 divided by 4 is a -3, but subtracting the letters. So in this case, we subtract 8 and 2, we get 6, and there's our answer. So in this case, the 8 is bigger, so it's a 1 on top with a 4, and then x to the 3rd power subtracted gets x to the 0, which then just gives us 1/4 as our answer. Here, 15 divided by 3 is 5. We see x, we get to the 3rd power, and y also to the 3rd power. Now the next type of problem is when we're dividing a polynomial by a monomial, and to do that, I'm going to rewrite the problem. I'm going to rewrite the monomial underneath each term. So if I write what I'm dividing by under each term, I can then do my division that we've just got done going through. So if I do that division, that's a -3. I subtract the letters, I get 6. I do this division, that's 1, and if I subtract, I get to the 4th. If I do that division, I get a -2, and I subtract, I get x to the 1st power. So my answer is a polynomial because I started with a polynomial. Here's another example of doing the exact same thing, except they wrote it over just 1, but I'm going to separate it. I'm going to go x to the 5th over the 2x cubed minus 9 over x to the 4th over 2x cubed, and then plus 8x cubed over 2x cubed. Now we do each part. This is 8, and I subtract my variables 2. This is still a fraction, so I'm going to leave it as a fraction because it doesn't go in evenly, but I have x to the 1st power. And then this last one divided does come out evenly, but we also get x to the 0, which is just 1, so there's my answer. Dividing with 2 variables doesn't change how we do the problem. We still separate each one, so 15x 5y4 all over 3x squared y. Then I have a -3x cubed y squared over 3x squared y. And then the last one here is 9x squared y over 3x squared y. So I go through my process of subtracting variables and dividing numbers. So 15 divided by 3 is 5. Subtract, I get x cubed. And when I subtract, I get y cubed. This becomes a -1 when I divide the numbers, and when I subtract the variables, I get x to the 1st power, and I get y to the 1st power. Once again, I divide my numbers, subtract my variables. They cancel, because they come 1, so then this is our answer.